Hello and welcome to my channel. In this series, I take you through past VCAA Maths Methods exam questions and provide you with a full work solution. In today's video, we'll be going through question 1 and question 2 of the 2020 exam 2, so that's the Calc-active exam, and question 1 and 2 of the multiple choice section. So as always, please attempt these questions now if you haven't already, and then feel free to continue watching for the solution. So I'll get started here. The question reads, let f and g be functions such that f of minus 1 is equal to 4, f of 2 is equal to 5, g of minus 1 is equal to 2, g of 2 is equal to 7, and g of 4 is equal to 6. Find the value of g of f of minus 1. Great, so essentially we've got 5 points that they're given us here. These are essentially just coordinates, so when x is equal to minus 1, we know that f is equal to 4, so that's obviously the other form of writing that. So 2 of these points are specific to f of x and the other 3 g of x. Relatively straightforward. So to evaluate g of f of minus 1, well, first we would just evaluate what is f of minus 1. It's telling us f of minus 1 is 4. So we can replace f of minus 1 with 4. So essentially what we would have now is g of 4. And g of 4, well, that's what this point is over here. And we know that's going to be equal to 6. So the answer to this is, answer to this is 6, so therefore the answer is D. Great, pretty straightforward. Nice question to start an exam with. Moving on to question 2. Let p of x is equal to x cubed minus 2ax squared plus x minus 1, where a is an element of the real set of numbers, where p is divided by when p is divided by x plus 2, the remainder is 5. The value of a is. So this question relates to remainder theorem, which ties in closely with factor theorem. So hopefully you guys can recall factor theorem. So factor theorem sort of states if p of, let's just use a random value c, is equal to 0, therefore x minus c would be a factor of whatever polynomial that you're dealing with, which would probably just be your polynomial p of x. So that would be a factor then. So remainder theorem sort of goes hand in hand. If this didn't equal to 0, if this was a non-zero value, so say we had p of c is equal to another constant d, therefore we know when we're dividing by, again, dividing by x minus c, we have this remainder d. So the only difference between factor theorem and remainder theorem is the outcome that you end up with. If you get a remainder of 0, that's factor theorem. If it's a non-zero remainder, then that's remainder theorem. So in this case, they're telling us that the remainder is 5. So therefore this constant d is 5. And what we're actually dividing in by is x plus 2. So this c will be value minus 2. So I'll get rid of this because this is all sort of in general. What that means for this specific question is we have p of minus 2 is equal to 5. So when dividing by x plus 2, so we would sub in minus 2, remainder is 5 there. So now all we have to do is take this polynomial, this cubic here, and let x equal to minus 2, equate that with 5, and we should be able to solve for a. So you can do this on a calc or do it by hand. It's not too difficult, so I'm just going to continue doing it by hand. Minus 2a minus 2 squared plus minus 2 minus 1 is equal to 5. So minus 2 cubed is minus 8. Minus 2a minus 2 squared is 4. So this can be minus 8a. Minus 2 minus 1 is minus 3 is equal to 5. Then if we add 8 and we also add 3 to both sides, we'll be left with minus 8a is equal to 5 plus 11, so that's 16. Last step, divide both sides by minus 8. We have a is equal to minus 2 as our answer. And hopefully that's one of the options here, and it is, that's E. Great. So not too difficult. If we look at the examiner's report, question 1, 86% of the people, 84% of the people answered it correctly. Question 2, 56. So it's interesting to see, question 2 is relatively straightforward. Hopefully most of you find it that way. And yet only around half the people answered it correctly. So just sort of have to be careful that you don't make silly mistakes along the way. There was no other specific feedback provided for this question, but I can imagine that most people are probably just a little bit sloppy with their remainder and factor theorems. That's not something that you maybe use too heavily. So we'll leave it there for this video. It shows the importance of remainder theorem and factor theorem. It's definitely still examinable. If you guys found the video useful, then please give it the thumbs up and share it with friends or classmates. If you're new to the channel, then please feel free to subscribe for more content like this in the future. Thanks for watching.